Okay, so our last video topic for today is going to be looking at something called factoring, okay? And it uses, in this case, the idea of the greatest common factor, okay? So before we talk in too much detail about it, I want you to think of factoring as this, okay? For now, this is the best way to think of it. It's distribution. Right? It's just like using the distributive property, but backwards. Okay? So basically, we can think of it as I give you the simplified form, and you go back to what it originally was. Okay? So for 3x minus 12, the first way that we can factor is with the GCF, like we talked about in the last clip. So if I look at my two terms here, my GCF, okay, let's see, this one has a 3 times x, and this one doesn't have an x, so I know that my GCF is just going to be a number. I think it's 3, okay? Because if I think about it, I can divide 3 by 3, and I can divide 12 by 3. Okay, so when I go to do my factoring, right, my reverse distributive property, okay, what I'm going to do is I'm going to put my 3 on the outside of the parentheses, right? I take that GCF and I put it outside the parentheses. Okay? So now the question is, well, what was left, right? So 3 times something gives me 3x, right? Because it has to work for distribution. That's going to be x, right? Because 3 times x is 3x. Okay? And then let's see. So I know I'm going to have a minus here. That seems to make sense. 3 times what would give me 12? Well, that's 4. Okay? And we should never get a factoring problem wrong, right? So let me quickly show you the check on this. If you're not sure, just go ahead and distribute it back, right? So this is my solution here. This is what I'm after. Okay? But if I wanted to check, what I can do is I can just take that 3 and distribute it back again. So I get 3x minus 3 times 4 is 12. Okay, so I've done it correctly. All right? So now let's think about a slightly more difficult example, okay? And we always want to start by identifying that GCF. So I have 15x plus 25x squared. So I know that I can factor out an x, right? We're thinking about our GCF, okay? Because this has an x to give. This one has 2 x's, but I can only take one. So let's see. I have an x, and 15 and 25, they're going to give me a GCF of 5, okay? So that leaves me here. I have a 5x, and I know I'm going to have a plus sign in here. So 5x times something gives me 15x. Well, let's see. I think 3 would do the trick, right? 5x times 3 is 15x. Okay. 5x, let's see. So I have 5x, and I need to turn that into a 25x squared. So I know I need another x, right? Because that gives me x times x for x squared. And 5 times 5 gives me 25. Okay. And I guess I'll do another check on this one. Okay, but again, when we're factoring, this is our stopping point. Okay. So my check would just be to distribute this again. Gives me 15x plus 5 times 5 is 25. X times x is x squared. Okay, so I've done it correctly, right? Because I got back to my original expression. All right, let's talk about something that can be a little bit tricky here. Okay, and what that's going to be is when my greatest common factor is actually one of the terms itself. So here, 10 and 2 give me a GCF of 2. X squared and x give me a GCF of x. Okay, so already I see that the GCF here is this term, okay? So let's see, let's pull it out. So 2x on the outside. Okay, So everybody think for a second. What will I need in here? 2x times what would give me 10x squared? Go ahead and think for about 10 seconds about that. Okay, so what I came up with here, and hopefully you agree, that 2x times 5x gives me 10x squared. Okay? Now the other one's tricky here. Well, sort of. 2x times what gives me 2x? Think about that one for a few seconds. Okay, so 2x, I get 1. Okay, I think 2x times 1 would give me 2x. Okay? So I think that's my solution. In the interest of time, I'm not going to do that check. Okay, I'll allow you to do it on your own. Right now, I want you to get started with the practice problems. Go ahead and do those now.